Okay, so solving radical equations. We just got done solving rationals. Now we're going to solve radicals. So those are square root equations. So a radical equation is an equation that has a variable and a radicand and has a variable with a rational exponent or has a variable with a rational exponent. So that's like the square root of x cubed plus 1 equals 65. Okay, if that doesn't make sense, it's fine. But a square root equation is just one, like the square root of x equals 9. Or something with a square root in it, okay? So radical equation, that can be any radical. It doesn't just have to be square roots. It could be cube roots, fourth roots, fifth roots, whatever it may be. And then the square roots are just the square root equations, okay? So here's some steps. We're not going to go through the steps, but they're there for you to read. So the first thing we always have to do is we need to isolate the radical. Okay, so I'm just going to draw a line down my equal sign, just so I can see I need to get that radical all by itself on one side of that line. Okay, in order to do that, I'm going to add the 5 over, because I need to get the square root of 4x plus 1 by itself, so I'm going to add the 5 over. So I get the square root of 4x plus 1 equals 5. Now that is isolated. In order to get rid of a square root, you have to square it. And whatever you do to one side of the equation, you have to do to the other side of the equation. So we're going to square both sides of this equation. The left side of the equation just becomes 4x plus 1. The right side of this equation, 5 squared is 25, so that just becomes 25. Now this is an equation that is pretty simple to solve. I'm just going to subtract the 1 over. So I get 4x equals 24. Divide by 4 and I get x equals 6. And then the last thing you always have to do is plug it back in to double check that it works, because there'll be some times that it doesn't work and you might end up with no solution. Okay, so I'm just going to plug it in. So the square root of 4 times 6 plus 1 minus 5 and see if that equals 0. Well, the square root of 4, or that becomes 24 plus 1, which the square root of 25 minus 5, and then 5 minus 5 is 0. So we're good. Really what I want you guys to do, though, is I want you to just plug in that very top equation. So I want you to plug this into your calculator and just see if you get 0 out. You don't need to go through all the math. You don't need to do that all. That's kind of, it's not necessarily a waste of time, but we have calculators for a reason. Let's use them. Let's utilize these calculators, okay? So I just want you to put it directly into your calculator just like that looks. Cool? Let's do another one. So we have the square root of 2x minus 5 plus 4 equals 7. So I'm just going to, I need to get that square root of 2x minus 5 by itself, so I'm going to draw a line down right there. I'm going to subtract the 4 over. So I get the square root of 2x minus 5 equals 3. Then I'm going to square both sides because I need to get rid of that radical. The only way to get rid of a radical is to square it. So you get 2x minus 5 equals 9. Then I'm just going to solve for x. So I'm going to add the 9 over. You get 2x equals 14. Divide by 2, you get x equals 7. Then we just need to plug that back in. Okay, announcements interrupted me. But, so we've solved for x now. So x equals 7. The last thing we always have to do, plug it back in, make sure it works. So I'm just going to check it. I have the square root of 2 times 7 minus 5 plus 4, and we have to see if that equals 7. Just plug it into your calculator. I went through all the steps right here. You don't necessarily have to. So you do get 7 equals 7, and that works. Okay? Let's see. Let's do this one. So this time, I have radicals on both sides of the equation, and they're already isolated by themselves. So at this point, I can just square both sides. So I'm going to square the left side, square the right side to get rid of those radicals. So that becomes 10x equals 9x plus 1. I'm going to subtract that 9x over, and I get x equals 1. Now I'm just going to plug that back in, see if it works. So I get the square root of 10 times 1, and I have to see if that equals the square root of 9 times 1 plus 1, which ends up being the square root of 10 equals the square root of 10. So we're good. Okay? Now this last one, this is the one that gets a little bit tricky. Take really, really good notes on this one. Okay, so I have to isolate my radical. It's already isolated, lucky us. Okay, now we're going to square both sides. So I'm going to square the left side, square the right side. The left side's easy. That just becomes 2x plus 3, and that equals x plus 2 squared. Now, x plus 2 squared is really x plus 2 times x plus 2, because that squared means that there is 2 x plus 2's. And then I'm going to use the box to multiply that out. So I have x plus 2 and x plus 2. X times x is x squared. 2 times x is 2x. X times 2 is 2x. 2 times 2 is 4. You combine like terms, and you end up with x squared plus 4x plus 4. Okay, I do not want to see, do not do this. X plus 2 squared does not equal x squared plus 4. I will literally cry if I see that multiple times, because I do already see it a lot. I don't want to see that. Okay, this is your warning. I don't want to see x plus 2 squared equals x squared plus 4. That's not right. You have to have that middle term also. So don't do this. Bad. That's really bad. Okay? Get out of here now. See, it's bad. We don't want it. Now, I have x squared, I have 4x, and I have 4. And I also have the 2x plus 3 on the left side. When you have a squared term, you have your x term, and you just have a constant. We need to move everything to one side and factor it. So I'm going to subtract the 2x, and I'm going to subtract the 3 over. So I end up with 0 equals x squared plus 2x plus 1. And now I'm just going to use the x here to factor that. So that's 1 on top, 2 on bottom. I have to see what multiplies to be 1, adds to be 2. It happens to just be 1 and 1. So then these factor down to x plus 1 and x plus 1. Then I'm going to just set each individual one equal to 0. So I have x plus 1 equals 0 and x plus 1 equals 0. This would have worked better if we had two different numbers, but it's okay. And then you just subtract the 1 over, so you get x equals negative 1. Then we just have to go back and check our answer, make sure that really works. So I have the square root of 2 times negative 1 plus 3, and I have to see if that equals negative 1 plus 2. And if you continue through this math, you do end up with 1 equals 1, so negative 1 works. Okay, I will see you guys tomorrow. Please remember to take the quiz.